Let's look at the quiz review worksheet for 6.2, 6.3, and slope fields. So number 1 says consider the differential equation dy over dx equals 2x plus 2 times y. And on the axis below, sketch the slope field for the given differential equation at the 15 points indicated. So we see here are the 15 ordered pairs. And I went ahead and I found all the ordered pairs, named them all. And one at a time, we're just plugging these x and y values into the differential equation, and the result of that value will be the slope or the y prime. So for instance, if I plug -1 in for x and 2 in for y, I'll get -2 plus 2, which is 0. 0 times 2 is 0, so therefore 0. So then after you name all the ordered pairs, you're going to go through, plug each of these ordered pairs into the differential equation, and the result will be the y prime, which we're going to interpret as slope and sketch slope short line segments on our slope field. Okay. So for instance, I'm listing the ordered pairs from the top order pair down to the bottom one. Okay, so I'm going by columns. So we see that these order pairs all have slopes of 0. So I'm going all the way down, 0, 0, 0, 0. And then the second column here, this has a slope of 4, so rather steep. And then less steep at +2. Okay, back down to 0. And then now our slope is in the negative direction, so -2, steeper at -4. And then starting the third column, this is the steepest, so I make this short line segment the steepest out of all the ones that I've done so far. Slope of +4, slope of 0, -4, and -8. Okay. Let's look at part B. Find the particular solution y equals f of x for the given differential equation with the initial condition of the order pair 0, 5. So we're starting with the differential equation, and we are simply taking the necessary steps to separate the variables and then find the antiderivative and get to the general solution, and then moving on to the specific solution by plugging in the ordered pair. So after we separate the variables, let's get the y's on the left, the y's and dy's on the left, and then the x's on the right. This is what we have. And then we take the integral of both sides. The left side is simply natural log of the absolute value of y. And the right side is simply power rule. So 2x squared over 2 plus 2x plus c. Next step, we raise both sides with e as the base so that we can get the y out from underneath this the natural log function. So y is equal to e to the x squared plus 2x times e to the c. So I'm splitting using the exponent property to separate and isolate this portion, which will eventually become c. This is a constant, e to the c is a constant. So this I can pull in front, so y is equal to ce to the x squared plus 2x. Okay. We have our general solution. Now we want to find our specific solution. So we plug the ordered pair in, 0 in for x, 5 in for y. E to the 0 is simply 1, so c times 1 is c, so c is equal to 5. So here we have our specific solution. Y is equal to 5e to the x squared plus 2x. Okay, part C, find the equation of the tangent to y equals f of x at the point where x equals 0 and use it to approximate f of 0.2. So all we're doing here is we're finding the equation of the tangent line, and after that we're just plugging 0.2 into the tangent line to approximate the y value. So we have the ordered pair at 0, 5, and 0, 5 is given from part B. Now we have the ordered pair. Now we need to find the slope. Right? So the way we find the slope is we need to be able to plug into the derivative. And what we do have is we were given the differential equation, right? That's what's given to us. dy over dx equals 2x plus y, 2x plus 2 times y. So we simply plug 0 and 5 into our derivative. And when we plug an ordered pair into the derivative, then that gives us back the specific slope, the specific rate of change. So we have our slope, we have our ordered pair, and we have our point slope formula. Okay? We plug the relevant information in, solve for y, and we get y is equal to 10x plus 5. So here is the equation of our tangent line. And the next step is we want to use this tangent line equation to approximate f of 0.2. So next we plug 0.2 in for x. So 10 times 0.2 plus 5, that will just give us 2 plus 5, which is 7. So therefore our approximation using the tangent line equation is equal to 7. All right, let's look at number 2. Number 2 says match the slope field to its differential equation and then sketch a solution that passes through the point. Okay, once we have that, we're also going to solve the equation and plug in our calculator to confirm that the sketch is correct. Okay, so first off, we want to be able to match this slope field with the appropriate differential equation. Okay, and remember, each of the differential equation is used to find the slope of each of these individual points. So we can observe some general things about this slope field graph. The first thing that I notice is that the slope is going to exist at all these points. Right? But if you look at option choices D and E, we see that we have a y in the denominator. So if this were in fact the differential equation for part D, then we should be expecting where we have portions of the graph that does not exist, where y is equal to 0. So technically there should not be any slopes at these ordered pairs. So we know that D is going to be out. In part E, we know that if the slope is determined by natural log of x, then we know that natural log, we know that x value cannot be a negative value. Otherwise, natural log of a negative value would not exist. So, but we see that we obviously have slopes that exist on the slope field for negative x values. So we know that part D is out. Okay. Part B is also out because x squared would mean that your derivative, your slope, will all be positive. But we do see some negative slopes here. So we know that B can't be it. Okay? And also we know x cubed can be it as well, because if we pick some ordered pairs, we see that it's not going to quite match up. Okay? So for instance, let's say I pick this ordered pair, which has an x value of 2. So 2 cubed is equal to 8. So I should be getting a positive slope here, but as indicated by this formula, but we see that the slope here is negative. Okay, so that's going to narrow it down to part C. Okay, so you can just pick some ordered pairs and see that these slopes is in general going to agree with our differential equation. Okay. So the ordered pair is at 1, -1. So we basically, in order to sketch our graph, we basically just we just follow the flow and the pattern of these individual slope segments, and we have it go through the ordered pair, and we just follow the graph as much as we can for what's shown. Right. All right, the next part, we want to solve the equation. So to solve the equation, we're going to separate the variables, and then from there, we're going to solve for the specific equation by plugging in the ordered pair 1, -1. So dy over dx equals xy. We separate the variables. Dy over y is equal to x dx. Take the integral of both sides. The left rule is natural log of the absolute value of y. The right side is power rule, so x squared over 2 plus c. We raise both sides with e as the base, so the left side will simply give us y. And the right side, will give us e to the x squared over 2 times e to the c. And so we know that e to the c is simply just going to be a constant, so we can pull the constant in front. So now we have our general solution. We can find our specific solution by plugging in our ordered pair. So 1 plugged in for x, -1 plugs in for y. E to the 1/2, we can divide to the other side. So -1 over e to the 1/2 is equal to c. So therefore, c is equal to -1 times e to the -1/2. Okay. And then once we have that, then we should have y is equal to -e to the -1/2 plus x squared. Okay. And so finally, y is equal to -e raised to the -1 plus x squared. So -1 plus x squared over 2. Okay. So if we plug this in our calculator, we should get an equation that is going to match what we just graphed on our slope field.